basically the aim of this project is identify a range of native plant species that can survive with Phytophthora, then examine whether seed enhancement technologies can help to establish seedlings in infested areas. So this project is carried out in 5 reserves located in Shire of Manderi, the Jarrah forest. So we have carried out a vegetation survey in these 5 reserves as the baseline of the study to assess the impact of the pathogen. Tom already discussed about the methods that we use for the vegetation survey. So my results analysis is quite different from his, because I'm considering each reserve separately to see the impact there rather than considering all of them together. So here, when you have a look at these bar graph, I have plotted the mean relative abundance percentage of each life form. So basically, I want you to have a look at red and blue bars. So except in Superblock Reserve, in all the other 4 reserves, we have observed reduced shrub and subshrub abundance in infested areas. And purple and green bars, herb and sedges abundance, they have increased in infested areas. So basically, when we look at this picture, so this is most of the reserves looks like this. There's nothing present in the understory, but in some reserves, herbs and sedges have colonized there. So we have some species present there, but there are no any shrubs or subshrubs. So there is a necessity to get back some shrubs to in these areas to ensure the ecosystem functioning. So as the second experiment, we did a pathogenicity experiment to identify native species that can survive with Phytophthora. So in the first experiment, I have selected like 50 species, native species, and they were tested for their seed germination, seedling emergence, and early survival with Phytophthora. And when I was selecting these 50 species, I basically considered the cost of the seeds and whether they are shrubs or subshrubs and whether they can provide food and fish to the wildlife. And I have 24 species that survive with Phytophthora during the early age. And then I did a proper pathogenicity experiment to see whether they are susceptible or resistant to the pathogen. So from these both experiments, we have selected 11 species that survive with Phytophthora. Basically, a majority of these species are mid-storage shrubs. The third experiment was assessing seed enhancement, whether they can help to establish seedlings. So these seed enhancement techniques is a quite new area. So first I will give you a brief introduction about this technique. So these are basically post-harvest treatments that we can apply to seeds. So these techniques has been successfully used in mine rehabilitation sites in Pilbara, Western Australia, and sagebrush ecosystem restoration sites in North America. So these techniques can provide a wide range of benefits to the seeds, such as they can improve seed handling and distribution through machines, protect seeds from seed predators, and improve seed germination and establishment. Moreover, they can deliver different compounds to benefit the seeds for their seed protection or recruitment. So there are 3 main types of seed enhancement. So basically we have, we can do physiological manipulation. We can either prime or acid digest seeds, or else we can do physical alteration. We can coat or pellet seeds, or else we can do flash flame to get rid of all the unwanted appendages and improve the flowability of these seeds through the machines. The third type is additives. We can add different additives such as biological inoculants, nutrients, and growth regulators to improve the performance of the seeds. So for my seed enhancement experiment, we selected 4 species which were tolerant to Phytophthora. So considering the fact that none of these seeds required any physiological manipulation, or they don't have any unwanted appendages that we need to get rid of, so we decided to use extruded pellet as the seed enhancement for these species. So the first seed enhancement experiment was carried out to determine optimum percentages of dry ingredients that we need to produce pellets. So as the first step, we scanned all this, extracted all the seeds and selected the healthy viable seeds. And then we measured all dry ingredients and we prepared a slurry using water. And then we prepared the pellets using molds. And in this case, we placed the pellets in the middle of the pellet. We placed seeds in the middle of the pellet. And once the pellets were dried, we set up the glasshouse experiment. So basically, there were 5 different pellet types, and control there were bare seeds. So in these pellet types, calcium bentonite and diatomaceous earth percentage were constant, whereas sand and topsoil collected from the reserves were varied. So here, moving to the results, here I have plotted seedling emergence percentage for all the 4 species against time. So as you can see, in all the 4 species, seedling emergence was considerably low in the pellets when compared to the control. However, in Acacia acuminata and Melaleuca seriata, base pellet shown in this red color emerged the highest out of all the other pellets. So we selected base pellet recipe as the best pellet formulation for the next experiment. So this is that formulation. So then we carried out another experiment to determine the optimum method that we can use to prepare pellet for each selected species. So we used the same base pellet recipe which we selected from the previous experiment, and we prepared pellets in 2 different ways. First, we prepared pre-made pellets in the laboratory beforehand using the molds, and then when I'm setting up the glasshouse experiment, we prepared field diploid pellets using syringes. So in both of these instances, we mix seeds with the slurry to place seeds randomly across the pellet. So similar to the first experiment, we again, seedling emergence percentage was plotted against the time for 4 species. So as you can see in Acacia acuminata, field diploid pellet, which is shown in green color, emerged best. And when we compare control and field diploid pellets, there was no significant difference between these 2. So we selected field diploid pellet for Acacia, and in Calathumnus and Melaleuca, pre-made pellet shown in green color emerged up to 100%, and they all passed the control. So we selected pre-made pellet. And however, in Hakia, unfortunately, both seedling emergence percentage of both pellets was significantly low when compared to the control. However, we didn't observe any significant difference between 2 types of pellets. So considering all the benefits that pellet can provide to the seeds, we decided to take pre-made pellets of Hakia to the field. So the final experiment is trying to establish these species in the reserves. So for the rehabilitation experiment, we selected 3 reserves out of 5 reserves that we did the survey. And in each reserve, we set up 6 blocks, and all of the 6 blocks were fenced out. And then inside each block, we set up 6 plots. Sorry. 6 plots inside each block for each species. And then these are the 6 species that I used for the experiment. So except Banksia, all the other species were tolerant to Phytophthora during the glasshouse experiment. However, Banksia was susceptible, considering the fact that we have seen a lot of Banksia in the reserves that they were surviving with Phytophthora. So we wanted to see how they perform in the field. So we decided to take Banksia to the field even though it is susceptible. So we had 6 species. As Acacia do have rhizobium inoculations, we decided to use Acacia rhizobium bacteria as an additive. So we had field diploid pellets with rhizobium bacteria and without rhizobium bacteria. And then similarly, Calathumnus and Melaleuca have mycorrhizal fungi associations. So we use mycorrhizal fungi spores as an additive. So we hope that these additives would provide more benefits for seed establishment. So Banksia and Hakia, they don't have any associations. So we didn't use any additives. So they just had control and pellets. So this is how it looked like when we finished setting up the experiment. So I finished setting up this experiment in this July. So each species treatment combination was replicated around 144 times in each reserve. So approximately there will be around 2,300 seedlings in each reserve. So now seedlings have started to emerge. So seedlings emerge from all the treatments of all species. So in Acacia, both Acacia species, control seedlings emerge first and then the pellets. However, in all the other species, I did not observe any difference of time that is taken to emerge seedlings. So treatments and controls took similar time. So finally, to conclude my presentation, when you have a look at these two pictures, these two pictures are from Quail Street Reserve, which one of reserve that I set up my rehabilitation experiment. So when you see this, when you compare these two pictures, you can clearly see that there's nothing present here. So the understory is just few of bosseas, nothing else. So there is a necessity to investigate different approaches that we can get back some species to these areas to ensure ecosystem functioning and ensure forest ability to support its dependent flora and fauna. So the ultimate aim of my research project is trying to replace lost susceptible species with native tolerant species so they can help to return lost ecosystem functions. So hopefully this research will be the beginning of this journey and we will be able to get a rehabilitated site like this in the future. Thank you very much.
That was wonderful. These long-term dieback sites are really heartbreaking. So, if you and your technology and your findings can help restore them, it's such a wonderful thing to be part of. Thank you. Please, questions from the audience.
With your pellets, did you bury them or just drop them?
No, I just dropped them on the ground. I didn't bury them. Just dropped them, yeah. Because
were they predated at all?
No, I didn't observe any pellet predation. But if you're doing it at a large scale, it's easier to drop them rather than bury them. So yeah.
I was just wondering if maybe selected your core species to do your for non-susceptible species to do your rehabilitation with, but you looked at what ecosystem services those individuals provide.
Yes, I mainly considered whether they can provide like a refuge to the wildlife and whether they can provide food sources. So that was the main thing that I looked into. Yeah, just checked. Yeah. No, I didn't do any watering. It's just rainwater. Yeah.
Thank you, Shanika.